Good morning, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. Today I am going to deliver a topic from the subject electromagnetic field. A topic is vector analysis. It comes under the unit static electric field. So first, what is the electromagnetic field? So electromagnetic it embraces the electricity, magnetism, electric field and electromagnetic waves. So in electromagnetics, the emphasis is on the space between the conductors and the electric and magnetic field in the space. So electromagnetic fields is also it is a approach essential for an understanding of waveguides, antenna, waves in space and particle field interactions. So electromagnetics is also provides a basic insight to the operation of basic circuit elements such as capacitor, resistors and inductor. So electromagnetic is a fundamental to the advancement of electric and computer technology. So examples of electromagnetic fields are communication, computer technology, antenna technology, military defense applications, and also biomedical applications also comes under the electromagnetic fields application. And the research area of electromagnetics are antenna, microwave, computational electromagnetics, electromagnetic scattering, electromagnetic propagation, radar and optics. So first, what is the electromagnetic? Electromagnetic is a study of effects of charges at the rest and charges in the motion. So some special cases of electromagnetics are electrostatics. Electrostatics deals with the charges at the rest. Magnetostatic deals with the charges in steady motion. Electromagnetic waves are the waves which are excited by the charges in time varying motion. So electric and magnetic fields are three-dimensional and they are vectors and they vary in space as well as time. They are governed by PDEs. So the solution of electromagnetic problem requires a high level of abstract thinking. So mathematics is a powerful tool. So that's why electromagnetic seems to be difficult. And here in case of electromagnetic field, transmitter and receiver are connected by a field. When an event in one place has an effect on something at a different location, we talk about the events are being connected by the field. So a field is a spatial distribution of a quantity. In general, it can be either scalar or vector in nature. So electromagnetic field, electric and magnetic fields are vector field with three spatial components. They vary as a function of position in three space as well as time. They are governed by partial differential equations. They are derived from the Maxwell's equations. First, what is a scalar? Scalar is a quantity that has only amplitude. Examples of scalars are voltage, current, charge, energy, temperature. Vector is a quantity that having a direction in addition to the amplitude. Examples are velocity, acceleration, force. So the fundamental vector field quantities in electromagnetics are, first one is electric field intensity, capital E. The unit here is volts per meter. Electric flux density. Electric flux density, it is represented as capital D. The unit is coulombs per square meter. And next is the magnetic field intensity. It is represented as H. The unit is amperes per meter. And magnetic flux density is B. The unit is Tesla or Webers per square meter. So the four fundamental quantities are electric field intensity capital E, electric flux density capital D, magnetic flux density capital B, magnetic field intensity capital H. So a field is a spatial distribution of a quantity. It can be either a vector or scalar. So we have three universal constants. First one is C0, which is nothing but it is a velocity of light in free space. It is 3 into 10 power 8 meters per second. And next one is epsilon naught, 8.854 into 10 power minus 12 farad per meter. It is a permittivity of a free space. Next one is mu naught, 4 pi into 10 power minus 7 Henry per meter. It is a permeability of a free space. So all the three constants are related by the equation C naught is equal to 1 by mu naught epsilon naught, and D is related to E and B is related to H by the relation D is equal to epsilon naught into E, B is equal to mu naught into H, where E is electric field intensity, H is a magnetic field intensity, D is a electric flux density and B is a magnetic flux density. A scalar field is a function that gives a single value of some variable for every point in a space. Examples are voltage, current. A vector is a quantity which has both a magnitude and direction. Example is a momentum, acceleration, etc. Examples of scalar field is a temperature. Example of vector field is a velocity. We have three coordinate system in electromagnetic field. They are Cartesian or rectangular coordinate system, cylindrical coordinate system and spherical coordinate system. Examples for Cartesian or rectangular coordinate system is the sheets, and wires or cables comes under cylindrical and sphere comes under spherical. So Cartesian coordinate system will be having a three coordinates x, y and z, and cylindrical it is r, theta and z. For spherical it is r, theta and phi. So the point in case of Cartesian coordinate system is represented as p of x, y, z. For cylindrical it is p of r, theta and z. For spherical it is r, theta and phi. And we have a unit vector. Unit vector along A is the vector whose magnitude is unity. So initially we will be representing unit vector as A vector is equal to A vector by modulus of A vector. And unit vector have a certain properties. So x vector dot x vector or y vector or y vector or z vector dot z vector is equal to 1, whereas x dot y or y dot z or z dot x is equal to 0. X cross y is equal to z and y cross z is equal to x and z cross x is equal to y. And next is the multiplication of vectors. We have either scalar product or dot product. Will be have two different interactions are there. First one is scalar or dot product. The calculation gives the work done by a force during a displacement. The work and hence energy are scalar quantities which arises from the multiplication of two vectors. So if A dot B is equal to 0, the vector A is 0 and vector B is 0 and theta is 90 degree. So that's all about the introduction to vector field in electromagnetic field. Thank you.